Hi study government engineers, welcome back. In this video we are going to discuss about most important topic, and most engineers ignore this topic. Most engineers doesn't look into this topic, that is the forward of the code, and also the classes like U1 to U6, that is doesn't come under any subsection. Like subsection A starts from UG, it doesn't starts from U. These kind of things most engineers omit. They don't consider it as a important thing, they don't consider it as a value added thing for their career, but it is very important one. You have to be start with the forward. Whenever you start a code, whenever you start any code, you have to start with the forward. Forward has many things. I have listed some of the things which is very much important for us. Before doing the calculations, we have to understand the philosophy, how the code works, what is the code trying to tell us. The code is not a handbook. Actually, it is a very important thing. The code provide rules. It is not a instruction manual. Instruction manual and handbook means each and every steps are ordered in a particular way. We have to follow each and every steps so that we can able to design a vessel. There are many handbooks for pressure vessels, but code is not a handbook. It is set of rules. There are some mandatory and non-mandatory rules also. We will see that code doesn't cover every situation. Some situations are there. Take a extreme situation as a bomb blast situation. In a particular zone, there must be some bomb blast, or there must be some frequent war, like any border kind of situations. There we are going to install the vessel, and inside the vessel there must be lethal substance. So we can't able to barely use the ASME Section VIII Division 1. It doesn't provide any rules for the blasting or any kind of situations. So it doesn't cover every situation. Experience remains critical. This is the main matter actually. When you are starting as a fresher, you think you have understood everything. You have started a design using a PVLite software or any other kind of software, so you thought that you can able to design a vessel completely, but no. Experience matters. Experience matters means you can able to design the vessel, but through experience only you can able to know, is the vessel or is any particular nozzles are feasible for this location, can we able to put that nozzle in this particular location. Just software provides, software is one kind of excel, right? It doesn't provide the real world situation. You have to understand the real world situation. For that you need experience. It requires engineering logic. As I already told, take it as an example as a nozzle. If a nozzle has to be placed in a critical location, we have to apply our engineering logic. Is it feasible to locate a nozzle or any pad or any kind of pressure pods over a particular thing, or in a particular part? It really comes from experience. Engineering logic comes also from the experience. Code cannot be replaced by a engineering judgment. Actually, this statement is different and this statement is different. But why there is two kind of statement? In the previous one, I have told that it requires engineering logic, but here I am telling that code cannot replace us engineering judgment, because code is rule. If there is some rule, we have to do that. With our engineering judgment, we cannot able to replace any rule which is provided by the code. And engineering judgment. What is engineering judgment? Engineering judgment is a philosophy which must align with the code philosophy. Code has some set of philosophy and engineering judgment has some set of philosophy, which both has to be aligned with each other. And safety is the baseline. In every engineering judgment, the safety is the baseline. As I already told you that if you are placing a vessel in the border or any frequently blasting or any bombing place, then the safety is very much important. You have to apply the engineering judgment. There you have to apply the engineering judgment, and you have to implement any other calculations regarding the particular situation that will be coming based on your engineering judgment. You cannot bypass anything explicit to the rule. As I have already told, engineering judgment cannot overrule mandatory requirement. This is also I have already told that always engineering judgment is another thing, and the mandatory rules which is given by the code, which is another set of thing. We have to follow the mandatory rules first, then we have to apply our engineering judgment. And in the forward, if you see the forward, you can able to see such a good thing. Here you can able to see mandatory versus non-mandatory. What are all the mandatory things you have to apply during the code, during calculation, or during design a pressure vessel, and what are all the non-mandatory things? The mandatory things are, the code has a word with shall. It means compulsory. You have to implement that in the design of pressure vessels, Actually it is a audit requirement. And there is some non-mandatory words also like should, may. Wherever these kind of words come on our class or in any paragraph or in any sentence, actually that means it is a good practice. We can able to use that and we can able to omit that also. If it is not required for us, we can able to omit that. But always it is a good practice to use if there is should or may in that particular word, and it is also recommended also. If you use that sentence or if you use that particular definition for designing a pressure vessel, it must be acceptable by the audit and it must be acceptable by the AI. And the most important thing, software responsibility. Most of you in my comments also I can able to see which is related to the software. Anna, which software you are using? Bro, which software you are using? I can able to see this command frequently. Code permits to use the computer. You can able to use the computer. It doesn't wants to do the paper calculations using the calculator and using bunch of papers with additional 100 and 120 pages. It doesn't actually compel you to do that hand calculations. You can use the softwares, you can use the computer, but the output must be verified. It must be verified by you or any other designers, any senior designers. It must be verified, and this output must be verified by the AI also. So if you told that I have given this value and the software has given me output, this is the thing, I don't know anything behind the process, means it must be a blunder mistake. You have to understand each and every process what the software is doing. Coming back to the question, coming back to the command, you frequently ask about the software, right? What software I am using? I am using one of the OG software, which is Microsoft Excel. Actually you think Microsoft Excel means it is just a basic software. No, it has a abundance of user. We can able to use Microsoft Excel for almost all kind of calculation in ASME Section VIII Division 1. Also we can able to use ASME Section VIII Division 2 also. For the part 4 we can able to use, but it is not recommended to use the software because we have bunch and bunch of formulas. The formula itself has almost one page of formula will be there. In that case, using different kind of software means it's not an issue, but you can able to use the Microsoft Excel to design a complete vessel. In real life, I am daily using the Microsoft Excel to do the calculations. If you are a beginner, you can start with Excel, and we have many other softwares which are dedicated for the pressure vessel design like PVL8, Compress, Autopipe, Dimmy, Probad. There are many softwares. These softwares are mostly dedicated to create or to generate or to calculate a pressure vessel. You can use that software. Actually that software is also based on Excel. Nowadays the PVL8 softwares looks completely different than the previous generations, because in previous generation I remember that only 2D sketch we can able to see. In first generation we can't able to see any diagram itself. We have to give the input and we have to get the output. If there is any error, we can able to indicate it in red or any kind of line. But nowadays 3D drawings are created. You can able to generate 3D drawing out of PVL8 software itself. It is getting very advanced. Once again I am telling, please use the Excel, please use the OG software that provides you the detail about how the other software works, and you easily able to validate the output of the PVL8 or any dedicated software for the pressure vessel. And also code provides responsibility. Who are all responsible for a particular vessel? Actually ASME is providing only rules. It is not providing any approval. This one is very important. Since we are designing a pressure vessel using ASME code, we can't able to say that ASME is responsible for that particular vessel. Ultimately you, the designer, you are responsible for the particular vessel. You means you, the manufacturer, and the person who witnessed the vessel, that means the person who inspect the vessel. Those are all the persons who are responsible for the particular vessel. ASME is not responsible for that. As I previously told, ASME provides the rule set. ASME does not check the design. ASME does just provide the rules. It doesn't check each and every design which you have created. There must be some flaws. Even it is generated by software, there must be some flaws. Manufacturer is the most liable person, because manufacturer will provide the guarantee. if there is any leak or if there is any damage in the pressure vessel, the manufacturer is the only responsible person to do those repair or any replacement. So ASME is not the responsible person. And in previous edition, ASME also provide who are all the responsible persons, like who are all the responsible designer, who are all the responsible engineer, what are the qualifications for the responsible designer, what are the qualifications for the responsible engineer. Those are all provided in previous editions. Now also actually it is provided in the division 2. If you want to know the qualifications, you can able to read the forward or any responsibility chart in ASME section 8 division 2. Why ASME evolves? As I already told in previous edition, you can able to see some different responsibilities and anything, but now you can't able to see those kind of responsibility in ASME section 8 division 1. That means industry has some failures, industry has some changes, industry has seen some changes, the rules are getting improved and improved, the previous things are not required, which are all omitted, and the current things which are required, those are all included. So ASME is getting evolved each and every 2 years, and also the new materials are added in each and every code. Most of the times you can able to see in previous code section 2 there must be some 150 or 200 materials, means in next edition there will be 2 extra material. I'm just telling the numbers for example. You can able to see some extra materials added for each and every code. In the previous edition also it will be there, but it is not directly given in the code, it will be given in the code case. There is something separate which is called code case. The code case, that material must be available, that will be included in the code. For example, if you take T92 material, that means grade 92 material. Grade 92 is a high alloy steel which is very good for creep. Those materials are still in code case. Previously it is on different code case, now it is on different code case. We are expecting the grade 92 material will be added in 2027 edition. And also fabrication. In fabrication there are new kinds of fabrications are evolving. We are less reliable on human and we are more reliable into machines and robots. So nowadays robots are doing the welding. Previously we have to qualify a person as a welder, and we are certifying that particular person as a qualified welder, but nowadays we can able to certify a robot or any machines which can able to weld, which can able to successfully do the full penetration weld. We can provide the qualification for the machine itself. Those kinds of technologies are evolving. So according to that, ASM is also evolving, and we are also accepting the real industrial experience. Whenever there must be change, code accepts and it includes that in our code, and we can able to use that for our next edition. Actually I have handpicked some important points for the forward. Have your code and read the forward. You can able to get some extra points which I have missed. Now we are getting into the U1. The U1 means U1 is a class which explains about the scope of this particular code. In this U1 you can able to see what are all the limits of section 8 division 1. It only talks about the section 8 division 1. Here you can able to see the limitations. You can read the scope. It is huge. I can't able to include everything in the slide, so please read that. It establishes boundaries and explains what ASME covers. The ASME first define the boundaries before the rules, and in the U1 you can able to see what are all included and what are all excluded. In the included list you can able to see pressure vessels, internal and externally pressurized, and also unfired steam boilers, and many more you can able to see. In excluded you can able to see the piping systems, pump and compressor, fire processed heaters, and you can also able to see any rotating components or any other civil structure or any other things which are all not included in the ASME section 8 division 1. And the important point is, not every pressurized equipment is a ASME section 8 vessel. Actually in previous slide I have mentioned that there are some boundaries in the pressure vessels. The boundaries means what are all the pressure, how much pressure a ASME section 8 division 1 can able to do the calculations, how much diameter we can able to do the calculations or design a vessel, and what are the materials we can able to do the calculations using ASME section 8 division 1. Those are all limitations limitations and those are all boundaries will be provided in this scope, which is very much important. Please look into the scope line by line. Here we are coming to the conclusion. So we have to use the code plus engineering thinking. We have to synchronize both. If you are not synchronizing both, you can't be able to design a complete pressure vessel. The pressure vessel design completes only with code and engineering judgment, and engineering judgment supports the code, not overrides it. I have already told you that we can't able to override the rules. The rules must be, we have to follow. After applying the rules, we have to use our engineering judgment also. And finally, before closing, this is a statement: ASME is more than equations. If someone doesn't know about the code, they will tell the code is full of equations, the code has only equations. You have to clear that person. Code is not only equations, it has safety philosophy, it has responsibility, it has a proper application. And finally, good engineer doesn't memorize ASME, they learn how to navigate and apply it. You doesn't blindly memorize the code, you have to understand the code and navigate the code, and you have to apply the code on a pressure vessel design. Okay, bye.